Hi everyone, and congratulations to Bob. I am sorry not to be able to travel to Maryland, and I do want to thank Jim and Brian for inviting me to present some recollections of my interactions with Bob, especially some experiments we did together on high pressure at both ISIS and at Los Alamos. I'm indebted to Richard Nelmes, now retired from the University of Edinburgh, for being a far better curator of photographs than I am, and for providing some of those that document our early experiments using the then just commissioned Parise, Edinburgh high pressure press at ISIS. Richard also passes along his very best regards to you, Bob, of course. I've highlighted here some relevant sections of the IPNS progress report of 1991, which I believe covers neutron work at Argonne in the 1980s. I first became aware of Bob's contributions while I was at DuPont Chemical in Wilmington, Delaware, starting in 1980. I had been hired to do zeolite synthesis working with Bob Shannon, but my group leader, Galen Stuckey, discovered I had a background in neutron Rietveld refinement from my time working with John Taylor at the Australian Atomic Energy Commission as a PhD student. DuPont needed a neutron guy, so I was tasked to split my time working with neutron data collected mostly at NIST with Ted Prince and with Dave Cox at Brookhaven, and I worked in my spare time on zeolite synthesis. I had some facility with using the Rietveld code, enough to know that it was cumbersome, especially for Fourier synthesis and magnetic structures. I had heard, however, that a new code developed by Bob von Dreele, and that it made life much easier, especially when dealing with time-of-flight neutron data. So Dick Harlow and I, Dick was heading the crystallographic effort at DuPont at that time, we traveled to Argonne to attend workshops on collecting data, analyzing with Bob's new software. Dick and I stayed in the old cottages at Argonne, had a great time enjoying a few days of workshop, which included happy hours after hard days at the computer terminal. High Pressure Neutron Science at Los Alamos did not begin with Bob, but Bob had a great deal to do with establishing truly high pressure science, by which I mean pressures above 5 GPa at LANSCE. Hydrostatic and quasi-hydrostatic studies using pressures on single crystals and powders around 2 GPa were routinely used. My involvement with high pressure, and then with Bob, coincided with my moving to Geosciences at Stony-Brook University. I moved to Stony-Brook in 1989 and continued my neutron work on microporous materials with Bob, Brian, and Dave Cox. This is the work I knew best, of course. However, I had moved from DuPont Chemical, where I had used high-pressure devices for synthesis, to a geoscience department at Stony-Brook, where there was a burgeoning high-pressure group complete with ideas on putting large-volume high-pressure devices on the Brookhaven National Synchrotron Light Source. The mineral physics team at Stony-Brook was installing a multi-anvil high-pressure apparatus at the White Beam beamline at NSLS. Why not try this with spallation neutrons, Bob and I thought, since the fixed geometry should allow for self-collimation, and we already knew Bob's software would provide precise structural parameters from energy dispersive, that is, time-of-flight neutron data. The multi-anvil device, the so-called Dyer apparatus, was developed for energy dispersive X-ray studies in Japan and was being installed at NSLS under Don Widener's leadership by, amongst others, graduate student Yuxing Zhao, who had moved to LANSCE after graduating. We mocked up this kit to test the data quality we might expect from a neutron time-of-flight experiment at LANSCE. This is an array of 4 equatorial angles with space for the incident beam and access to plus and minus 90-degree detector banks. Soon after this mock-up was completed, however, it was abandoned, as the next slide will explain. Although the neutron Dyer was shelved, a multi-anvil effort was resurrected by Bob at the Hippo beamline at LANSCE in the late 90s. What prompted a shift in emphasis was a series of experiments in which we were observers to experiments being carried out on the high pressure beamline at ISIS in Chiltern, close to where Bob had spent his sabbatical at the Rutherford Appleton Lab in 1978-79. The Paris-Edinburgh team was led by Jean-Marie Besson and Richard Nelmes. These photographs were provided by Richard Nelmes and show Bob discussing the Paris-Edinburgh cell, an opposed anvil device as opposed to a multi-anvil device, and this is illustrated further in the next slide. Here are Bob and Jean-Marie Besson while pressure is being increased in the Paris-Edinburgh cell. I'm not too sure NAPAC would recommend the lever extension. Here are a series of photographs of the press itself. The innovation for neutron scattering is the compact nature of the device, the ease with which it could be inserted into the limited space available at the Polaris beamline, and the opposed toroidal anvils which allowed a substantial sample loading. Further, the sample chamber could be flooded with deuterated methanol-ethanol mixtures to ensure hydrostatic conditions to about 10 GPa. A great deal of science can be and was done with this hydrostatic condition up to 10 GPa, and eventually with cooling to about 100 K. 1 year or so after these observations at ISIS, the Paris-Edinburgh high pressure cell was installed at HIPD at LANSCE, with Bob and the PE crew carrying out the first experiments on the equation of state of boron during the 1992 run cycle. In 1992, we began collecting data on hydrogen-bonded systems, first at LANSCE and then later at ISIS, and these measurements proved to be very fruitful. Unlike spectroscopy, diffraction allows for the relatively unambiguous location of hydrogen, deuterons in the case of most powder studies, and the prototypical hydrogen-bonded solid is the layered structure of magnesium hydroxide known as brucite. Working with Bob at HIPD, we studied the deuterated version to about 9 GPa and were able to resolve the disorder of the deuterium and documented the increase in the ODO angle and the hydrogen-bonded distance as a function of pressure. Well, congratulations once again, Bob. You have greatly enriched my scientific endeavors, and it has always been great to be with you. Our initial trip to ISIS, I think, was a revelation to both of us, and not only because of our introduction to the Paris-Edinburgh cell. The most surprising part of that experiment was Besson's insistence on finishing each experimental run with a picnic, and I'm putting picnic in air quotes, on top of Polaris at ISIS. The picnic involved French food and just a small amount of wine, and a great deal of discussion of the advantages and disadvantages of diffraction versus spectroscopy for the study of hydrogen bonding in ice. Again, I'm sorry not to be there, and please enjoy the day.